Now we're going to look at composition of functions. We're going to first try to understand what it means to compose functions, and then we will go ahead and compose some functions. So function composition involves applying one function to the result of another. So here's how it's denoted: f, then the little o, gx, which is the same as having g of x as an input to the function f of x. So let's go ahead and try this. So g(of) of x, what this means is that we want g of f of x. So this is going to be g of f of x is x squared. So now when we compose this, so remember that g of x is x plus 1. So for every instance of x, we're going to replace it with x squared. So it's going to be x squared plus 1. Now let's try f o g of x, which is f of g of x, which is going to be f of x plus 1, which is going to be, so f of x is x squared. So in place of x, we're going to in place of x, we're going to have x plus 1. So this is going to be x plus 1 squared, which is x squared plus 2x plus 1. So f o g x is going to be x squared plus 2x plus 1. So f of x is equal to 3x. Alright. G of x is equal to 6x plus 1. What is g o f of 3? So this is going to be g of f of 3. So let's find what f of 3 is first. F of 3 is going to be 3 times 3, which is 9. Then we're going to use that as an input to g of x. So g of 9 is equal to 6 times 9 plus 1, which is 54 plus 1, which is going to give us 55. Now f o g of negative 1, so this is the same as f of g of negative 1. So we're going to find g of negative 1 first. G of negative 1 is negative 6 multiplied by negative 1 plus 1. Sorry, this is positive 6 multiplied by negative 1 plus 1, which is negative 6 plus 1, which is negative 5. Now we need to find f of negative 5, which is going to be 3 times negative 5, which is negative 15. So f of x is 3x squared. G of x is 4x minus 3. So g small o f of x is going to be g of f of x. So g o f of negative 4 is g f of negative 4. So let's find f of negative 4 first. F of negative 4 is 3 times negative 4 squared, which is 3 times 16, which is 48. So now that becomes an input to the g of x function. So we now have g of 48 is going to be equal to 4 times 48 minus 3, which is 192 minus 3, and that should give you 189. What about f o g of 5? this is going to give us f of g of 5. So what this means is that we're going to look for g of 5 first, and then our result is going to be an input to f of x. So g of 5, so g of 5 is equal to 4 times 5 minus 3, which is going to give us 20 minus 3, which is 17. Now this becomes the input to f of x, so f of 17 is going to be 3 times 17 squared, which is 3 times 289, which is going to give us 867. Now finally, f of x equal to 4x, g of x equal to x squared minus 1. G of f of 2 is g of f of 2, which means that we're going to look for f of 2 first, and then we use it as an input to the g of x function. So f of 2 is 4 times 2, which is going to be 8. And then we now have 8 as an input to g of x. So it's going to be g of 8, which is going to be 8 squared minus 1, which is 64 minus 1, which is going to be 63. Now, f of g of 2 is going to be f of g of 2. So the first thing we're going to have is g of 2, which is going to result in 2 squared minus 1, which is 4 minus 1, and that's going to be equal to 3. And now 3 becomes an input to f of x, which is 4 times 3, which is equal to 12. So this is how you manage the composition of functions.